But before we really start, I want to ask if paper number 83, paper number 84, 91, and 92 are already here. Please briefly type in your, just say yes quickly and in the chat box so I know you are already here. Okay, good. 84 is here, 83 is here. So what about paper 91 and 92? Authors from Georgia Tech. Okay, good. It seems like we are here. So yes, I'm ready in any second.
Thank you very much. So we're going to start the session right now. Our session chair is Rongo. The session is all yours.
Okay, thank you, the host, for the introduction. My name is Rongo Hu. I'm the session chair for this session D3, Robotic Machines, Devices, and Factors. We have 4 online presentations and 1 video presentation in this section. So just before we really start, just a some quick announcements. So each of this presenter will have 8 to 10 minutes to present maximum, and followed by a 3 minutes Q&A session. I encourage all the audience to ask questions, as well as the audience online to type in your questions in this chat box. And so when you reach the 8-minute mark, I will also give you a brief hint so that you have 2 minutes left to wrap up. So yes, so our first presenter is paper number 83. The title of the number is Solution Kit for Automated and Robotic Facade Upgrading. Dr. Kepa Iturralde from Technical University of Munich. So Kepa, the floor is yours.
Thank you. Am I audible?
Yes, perfect.
Thank you very much, Dr. Rongo Hu, for the presentation. Actually, Rongo is my colleague. I know him well. Thank you, Rongo.
No worries.
Okay. Good. I think now you see my screen also. Good. So this is about solution kits for building renovation, facade renovation. I think I have been working on this topic, I think, since some years already. There will be introduction, research gaps, solution kits, and conclusions. Good. So what is this about? One of the goals of the European Commission, I would say the entire world currently, is to reduce the energy consumption of the existing buildings. One way for doing so is adding a new technical layer on top of the existing building. For doing so as well, there are several possibilities. One possibility is of doing it manually with a scaffolding, which implies risks, disturbing the building users and so on. And lately, on the latest 20 years, there has been the solution of using prefabricated elements that have been added to the existing building. So for doing so, we need, of course, to acquire or very accurate data acquisition of the existing building. And we need to process that information to design the prefabricated modules with a high accuracy, okay? The problem with accuracy, well, the issue with accuracy is that if there is not enough accuracy, there might be thermal breaches and water might come inside the building. That's something that we don't want. So a relative accuracy of 1 millimeter is needed between the panels, which is a huge accuracy. Besides, in the ENSNER project, I forgot to say in the beginning, I'm working now on the ENSNER project funded by the European Commission. In the ENSNER project, there will be in these prefabricated panels solar cells and also hot water absorbers, solar water absorbers, let's say. So, which implies a higher accuracy, if possible, because pipes and cables need to be joined somehow. Well, this is an accuracy matter. So we have first that data flow. There's one subcategory of this process, data flow. The next subcategory is manufacturing offsite, and the latest subcategory is on-site installation. Well, after the prefabricated element has been manufactured, it's transported to the site, and we can use either cranes or robotics or whatever to install these elements on top of the existing building. There is one very important thing to say. You need connectors. You need some sort of connectors, anchors on the existing facade, so you can add on top those prefabricated elements. And the position of these connectors needs to be given to the operator or to the robot, meaning that there must be some coordination among them. Okay, 3 minutes already. So in the research gaps, we realized that in previous projects, we need to avoid visiting the on-site building several times. We need to avoid, for instance, let's say that there is a building in New York or in Bogota, and we are based in Munich, as is the case. And well, in order to build or to model the building, it's quite difficult. It's not convenient to visit the building sometimes, because it implies spending a lot of money, time, resources, and so on. So we need to avoid time-consuming data acquisition and avoid recurrent data acquisition. Another topic is that we need to define the shape of each of the prefabricated modules, meaning there is an engineering process. But of course, we need to, with current parametric tools, this should be avoided. And well, another point is that for manufacturing all these elements in a factory, the CAD/CAM should be agile enough to, or if we are using robot for assembling these prefabricated elements, the information between the CAD and the manufacturing process should be quite agile. So in the first solution kit that I'm presenting here, the idea was to generate the building model with online data and some pictures given by the client. So we generate the building model more or less automatically by using OpenStreetMaps, pictures of the client, and then with that building model, we can automatically generate the layout of the prefabricated models. This is the scheme we used. We use OpenStreetMaps. We are using FreeCAD for developing these systems. We use photogrammetry. AI will not necessarily algebraic formula, but also I think it's better to use lines in this case, for instance. And it's well, I think it's interesting. By using OpenCV libraries, we flatten the facade and we define the place of the windows. Well, I can show you this video very fastly. So we first import the information to from OpenStreetMaps. Sorry. Then we use aerial data, also aerial pictures, for instance, to match the OpenStreetMaps with the current information. We use pictures for defining, let's say, defining the shape of the facades. We can select manually the windows. We are now in the process of selecting the windows, recognizes the windows on the balconies automatically, not for this not for this paper. We didn't have it ready yet. Well, we recognize it, and at the end of the process, we are able to define the building. So with the building already, one moment. With the building already, my program needs to be restarted because of the video. 1 minute, please.
Yes, go ahead. Take your time.
Only one, I guess 1 minute. Okay. Sorry for this. Wanted to do this a bit faster than, so there is no. Okay, now you can see my screen again, right?
Yes.
So we generate the building model. We have the building model already. And with this information, facade by facade, we can define the shape of the modules in a few seconds by an algorithm we developed. We optimize the amount of solar cells that can be added on top. The solar cells are not that problematic, but the hot water solar absorbers, these are quite problematic because they are standardized, they have a different defined shape. So we need to optimize. In this project, we are using 12 different sizes, and you see here in green the algorithm we developed and how we optimize this shape to this to optimize the amount of area that we can cover with these solar absorbers. We don't only define in this process the layout of the modules, but also where the connectors should be. Okay, so we can say that the connectors that need to be placed are on that area, and we have developed by using April tags and OpenCV libraries. We are able to, by using pictures and not using total station, to measure more or less automatically the places, the location of these targets or April tags. Again, those locations are where the prefabricated modules connector will be placed. Okay, and you might say, well, placing these connectors might take a lot of time, which is true. We realized in previous projects that this is a very time-consuming activity. We also used in the previous projects 3D point cloud and so on. I'm not very happy with the result of that because the accuracy was quite low. And that's why we are developing in this project also the way of using a drone for placing those targets. So that's explained on the paper. We might have some inaccuracies while placing those first targets on the existing building, but then we can solve it using the so-called matching kit interface. But this is something that's already explained in previous literature.
So 2 minutes to wrap up.
Yes. With these prefabricated modules, as I said, we are also experimenting how to automatically assemble the modules by using robotics. First, we made some sort of simulations in ROS. So what we are trying to do here is to connect every prefabricated modules CAD or drawings with the cam of the robot. Okay, and lately it's not only simulation. We have done let's say we have done some experimentation also in our lab. Okay, this is quite slow but we are performing quite okay. And now we are in the initial phase, but well, in principle, this is all still a work in progress. Well, it was a work in progress when the paper was submitted. Now we have made some advances. And of course, now we are looking how to maybe get closer to the market by applying this technology. So thank you very much. As I said, this is a project-based research. There are plenty of partners in this research. And it is funded by the European Commission. So thank you very much. Questions, please.
Thank you very much, Kepa, for your wonderful and systematic presentation. So I didn't find any questions in the chat box, but I would like to ask the host in the auditorium if there's any questions.
This is Varun. Professor Dr. Kepa, I have a question. What are the pre-settling activities that is required for this kind of experiment to be done? Like, is there any like I have seen your presentation in the last ISARC where it was like presented the best paper over. What are the, for example, if we want to start on a new project, what the company have to do?
Well, there are different aspects in this case. I mean, the previous projects was based on only facade installation, but in this case is for building renovation, facade building renovation. So is your question what is necessary to get the project, or what kind of information we need for developing the facade, or I don't...
Okay, so my question is about practical implementation. Once you have all the things set up, physically, if you want to install, what will be the stepwise, like pre-step procedure, like for installing the robot, like?
Well, in this case, for the installation process, as you can see here, CIS31, we are not using precisely an installation robot. We are more using a drone, which requires a positioning of the drone within the built environment. In the previous project, also, let's say the robotic device had to be positioned in regards to the built environment. In that case, it was a building structure, but you need to position somehow because you have plenty of references and you need to reference your robotic device in regards to the existing building. In this case, we will use April tags on known position to locate the drone in regards to this April tag.
Okay.
Probably the drone will have some April tags as well, and we will use a quite powerful camera to locate with sufficient accuracy. Sorry, the location of this drone. But yeah, but I would say in building erection, so in new buildings, not only in building renovation, the issue is the same. And if you talk with also, I mean, it's the same also in the rest of the industry. If you talk to facade manufacturers and installers, they are all the time struggling with the positioning of the connectors, the positioning of these elements. So, yes.
Thanks, sir.
Okay,
Thank you.
I think we need to move on due to time constraints. Kepa, thank you very much again. I was trying to ask some question, but actually it's the same question as the other guy. So thank you. And we are going to have the next presenter. The presenter from